We're going to work on lesson 210 today, last lesson in chapter 2. So if you're missing any homework or anything like that, make sure you're getting on top of that. The test will be coming up soon then. We're going to talk about two main topics here. They are percent of change and percent error. Their formulas are very much alike. So when you want to find the percent change, we're talking, if you said, Mom and Dad, my score went up by 2, that might not be a big deal if there were 100 questions on the test. The amount of change percent-wise isn't very great, but if there were only 6 points on the test and yours increased by 2 from what you had last time, that 2 carries more weight. The percent of that 2 points is a bigger deal. So when we're trying to figure out percent change, what you want to do is find the amount of change and always show it as positive. So some of you can think of it as the absolute value of the amount of change, if you like. The absolute value of the amount of change divided by whatever the original amount was. The original amount would be like whatever number they give you first, or if it's a story problem, whatever would have happened first. You always want to describe the change as an increase or a decrease unless it is stated as such in the problem itself. So right now, I start with that part. If I have a price go from 80 to 74, it's decreasing. So I'm going to write decrease to start and just shorten it. Then you're going to subtract these two numbers. You're going to show 82 minus 74.5. And the original was 82. So you have to show this in steps though, so that the reader can understand your work. You subtract your two numbers first, and you get 7.5 or 7.50 over 82. Show that step, then divide those two. And this number is quite long, you know. So what you're going to do is you're going to need to represent this as a percent. So you could multiply by 100 if you want. And you can see that it would be like 9 point, or you can't see that, sorry, 9.15 or 9.1. So when I take these two and divide them, I will then multiply by 100 real quick. And then I'll say I had, 0.091. When I multiply by 100, that turns into about 9.1%. When I think about what I want to see for your work, it's what did you subtract? What was the result? And then either one, you can show this or not. This is the answer I need to see. You can skip writing that though, because it's so repetitive. So right here, if I went from 3 to 350, it would be an increase. I'm going to subtract these two. You could say 3 minus 350, or you can say 350 minus 3. It's not going to change what you're doing here. So I'm going to say 350 minus 3 over the original. You always want whatever this is to be positive. So if you ever get a negative, flip it positive. So you have 0.5 over 3. You're going to divide those two to find out how much that 0.5 is worth. Is that 0.5 a big deal or is it not? Higher percents being a bigger deal. You'll divide those two. We get 0.16 repeating. So I would take that times 100 or slide the decimal over 2. And I'm rounding this, so I would say 16.6 repeating percent. A person could put 7 there too if that's how they want. You're going to see some word problems of this nature. All that's different really is they might throw in a date that you don't need. If they said December 4th, the 4 is not a number you need. And they typically tell you if it's an increase or a decrease. Story-wise, you try and tell what would have happened first. That would have been that one. So that's going to be my original. Time-wise, it happened first. So I'm going to take 4.1 and subtract 2.8. Remember, those can be subtracted in any order as long as you turn the answer positive. Put that over the original. I'm going to subtract 4.1 minus 2.8. and I'm going to get 1.3. Keep that over 4.1. I'm going to divide those two, and I get 0.3170 like so. So I'm going to multiply by 100 or slide the decimal over 2. And depending on what you're supposed to round to, this might be 31.7 and it might be 31.71%. I'm going to say 31.7%. So now we've got our change in precipitation. It says the average in Chicago in June is 4.1. The average in December is 2.8. What is the increase? How much is that? There's the change divided by the original. It's about a 31% increase. The higher that percent is, the more the change is, the more meaningful that change is. Let's take a look at percent error. So percent error is the amount of error, and I want to clarify that and say the amount of error, the difference, you can say. And again, you're going to do the exact same thing. You're going to find out this number as a positive. So you can either say keep it positive or you can put some absolute value symbols there. So you're going to find the difference between whatever measurement is actual minus whatever measurement is estimated or whatever, guessed. You'll find that difference and you always put it over the actual. This time it won't be over the original, it's the actual number. It says you think the distance between your house and a friend's house is 5.5. The actual is 4.75. So I'm going to find the difference between those two. What I'm going to divide by is what it really was. I made a mistake here when I did this, 5.5 to 4.7. My question is, or what you're trying to find out now is that mistake significant? Is it a high percent of that you were off by? The actual measure was 4.75. You're going to subtract those two. If I can type correctly. And I get 0.75, and I'm going to divide that by 4.75. And then, again, I get a number that keeps going, so I might multiply by 100 or just visually slide the decimal over 2. 8 would tell 7 to go up, so this would be 15.8%. So this is about 15.8%. You estimate that your friend's little brother is 12 years old and he's actually 8. What is the percent error in that estimate? Subtract the two numbers. I always subtract in a way that just gets me a positive. I put the bigger number first. You're going to then divide by whatever actual is. You're going to say here 12 minus 8 is 4 over the actual. Divide those two and get 0.5. You can either slide the decimal over 2 or multiply by 100, and that would give you 50%. So that's a pretty significant amount of error. You might be off by 4 on something that was out of 60, and that 4 doesn't carry as much value, but 4 out of 8, much more meaningful. So that's our percent change, percent error for lesson 210.